Good afternoon, class. We are looking at section 2.1, limits of sequences. Here's part 2, the second part of what we started. And I'm going to remind you of arithmetic and geometric sequence. Arithmetic sequence is in the form of a sub 1 plus a sub 1 plus d, and it continues, which means we are adding a constant distance or difference. So a sub n plus 1 is a sub n plus d recursively, and it's a sub 1 plus n minus 1 times d explicitly. Example 1, 5, 9, 13. 1 is the first term, and the difference is 4. In the case of a geometric sequence, a sub 1 r times r, and we have a constant ratio of r. Recursively, it's defined as a sub n plus 1 is r times a sub n. Explicitly, it's defined as a sub n equals a sub 1 r to the power of n minus 1. And in this case, the first term is 1, then you multiply it by 4. And so what happens is that if we add them up, the sum is a times 1 minus r to the power of n over 1 minus r. This s sub n is called the partial sum. We will look at the proof, although you're not responsible for that. And when r is between negative 1 and 1, you remember the theorem, this goes to 0, and therefore we get a over 1 minus r. Let's look at the proof of this, everybody. The geometric sequence becomes a geometric series when we add them up, a plus ar squared all the way to the end. So summation of n equals 1 to infinity ar to the power of n minus 1, needless to say, a can't be 1. If we want s sub n, the partial sum of the first n terms would be this part. Please understand this is the first term, second term. So this one with the n minus 1, this one is the nth term. We're going to multiply both sides by r, which means this becomes ar. So r times s sub n. This is ar, this is ar squared, this is ar cubed. This one becomes ar n r to the power of n minus 1, and this one a r to the power of n. So this is what we get. All right. Let's subtract this one from this one. Meaning this minus this. And when we do that, this one remains. This cancels out this one. This cancels out this one. And it continues to the end. And this cancels out this one. What remains is a from the first one, a times r to the power of n for the last one. And that's the answer. So with that being the case, let's factor the s sub n on the left, a on the right. Let's divide 1 by 1 minus r, and this is the proof of s sub n. Now, if this thing continues indefinitely, and we want the total sum, we have to take a limit of that, and we let n go to infinity. And this may go to infinity depending on the value of r. If r is between negative 1 and 1, r to the power of n goes to 0. as you recall from the theorem, in which case we're going to write this is going to go to 0, and that's why we end up with a over 1 minus r. I hope everybody's fine with that. Again, it's pretty straightforward, I believe. We want to add these terms, and that means we are adding 1/2 and 1/4 and 1/8, and it goes all the way to the end indefinitely. We notice this is a geometric sequence because we are adding them. It becomes a geometric series. The first term is 1/2. And if you notice, when you multiply by 1/2, you get 1/4. By 1/2, you get 1/8. By 1/2, you get 1 over 16. Or you might say, I'm going to divide this one by this one. So r becomes 1/2 as well. Okay. So you're multiplying this one by 1/2, this one by 1/2, and therefore r is 1/2. We are going to use this where a and r are both 1/2. 1 minus 1/2 is 1/2. This ratio is 1. Let's express this repeating decimal 0.46 bar as a rational number in a fractional format. As you know, by definition of a repeating decimal, this means 0.464646, and it continues indefinitely. That's the meaning of it. So I'm going to say it's going to be this part plus this part plus this part, and it continues indefinitely. This part, and we can write them in two ways. We can write them as a fraction or as a decimal. Understand this is 0.46 or 46 over 100. This is 0.046 or 46 over 10,000 or 100 squared. This is 0.00046 or 46 over 100 cubed, or 1 with 6 zeros. That means the same thing. What we need to notice is that this is also a geometric sequence, with this one being the first term, either 46 over 100 or 0.46. What is the ratio? What is the constant that we are multiplying by? Notice I wrote it in this format so you can see this number is 100 times larger than this. So if the fraction is 100 times larger, if the denominator is 100 times larger, the fraction is 100 times smaller. So 1 over 100 or 0.01. You can divide this number by this one or divide this number by this one, and you see it's 0.01 or 1 over 100. That means, again, we can use this formula, which means A is 0.46 or 46 over 100, and R is 1 over 100 or 0.01. And I'm going to look at them both ways. If I want to go with a fraction, I'm going to write 46 over 100, and the bottom is 1 minus 1 over 100. If I want to go with the decimal, I'm going to change this to, let me just give it some space. I'm going to change this to 0.46, and I'm going to change this to 1 minus 0.01. And if we want to continue with the decimal, we get 0.46 over 0.99. I'm going to come back to that in a moment. And if we want to continue with the fraction, it's a complex fraction. We're going to multiply the top and the bottom by 100. When we do that, the product here is 46. and the product here is 100 minus 1 or 99. This can't be simplified any further, and of course 0.46 over 0.99 must be changed and written in this format. Okay, everybody? So the final answer is 46 over 99. So if they ask you to put it in a rational number format, that means in a fractional format, your final answer is 46 over 99. We are going to move on. What if we have 5.75 bar as a rational number? We want to change it to a rational number. Again, you have a repeating decimal. 5 doesn't change. You are going to work on this and write it as 5.757575, and it continues indefinitely. And for this part, so we're going to keep the 5 and we're going to work on this part just the way we did in the previous example. So we can write this as 75 over 100 or 0.75. We can write this one as 75 over 100 squared or 0.0075. And this last piece, we can write it as 75 over 100 cubed or 0.000075. Either way is fine, as long as you understand you have a choice of going with fractional format or decimal format. Now, 5 will continue being added to what we are doing here. This is the portion we are going to look at using the geometric sequence, and now becomes a series because we are adding. This is A, the first term, 0.75 or 75 over 100. In fact, I don't want to even simplify it. I will simplify that. I just want to make a point which one is A. And R is like before, is 1 over 100 or 0.01. Again, how do you know that? This denominator is 100 times larger than this denominator. This fraction is smaller by a factor of 100. So 1 over 100 or 0.01. Therefore, if I want to write 5.75 bar, is 5 plus 0.75 bar. And this is the part that I can show it just as before in the previous page, using A over 1 minus R, using fractions, or I can use decimals. Instead of this, I'm going to put 0.75. Instead of this, I'm going to put 0.01. So this is 0.75, and this is 1 minus 0.01. And let me erase the mess again. And so this one, everybody, if I'm just interested in finding this. So this one is 0.75 over 0.99. So we're talking about this part. So I'm going to come back to this. We are not finished, but I wanted to show you what happens to it, because you have to change it to 75 over 99 and do the math. This part, however, it's a complex fraction. You're going to multiply the top and the bottom by 100, which means now this is 75. This is 100 minus 1. And so this portion is this portion, and the 5 remains. Needless to say, 75 over 99 will change to 25 over 33. And that's what we are doing here. This is the same as this part and must be simplified. If they don't accept this as a mixed number and they want you to change it to a fraction, you can multiply 5 by 33, becomes 165, added to 25, and you get 190 over 33. It depends how they want you to represent the number. Mixed number or improper fraction, whatever they ask you. All right, if we look at this example, the geometric recursion sequence is example B sub n is 3 times 2 to the power of n, with n being 0, 1, 2, to infinity, and you remember the solution for geometric sequence as far as recursive format or explicit format is concerned. We have this in this form, and we notice according to this that A or B sub 0, in some texts they use B sub 0, in some texts they use A. That is number 3, and R is 2. However, if you want to expand that, if you plug in 0, 2 to the power of 0 is 1, you get 3. If you put 1, you get 2 times 3 is 6. If you put 2, 2 squared, 4 times 3 is 12. So this is the geometric sequence, and clearly you can see that B sub n plus 1 is R B sub n, or 2 times B sub n, and A and B sub 0 are both the same, or 3. Now, if we modify this, because we have discussed it in the summary, now we are going to elaborate on this. If we modify it as the following, let's modify the geometric equation by adding a constant term C. This difference equation arises for many real-world examples, such as when a patient is given some medication on a regular basis, daily or so. B sub n plus 1 is R B sub n plus C. It's important to understand R is the portion, the percentage that remains in the body, and C is the constant. It's the fixed amount of a drug that we give it to the patient at every time step, every 8 hours, every 12 hours, every day, every week, and so on. In that case, this will give rise to this solution. So B sub n plus 1 is R B sub n plus C. The solution is B sub n is B sub 0 R to the power of n, just like this one. This part is added because of this plus C times 1 minus R to the power of n over 1 minus R. Again, instead of B sub 0, one may use A. And I have the proof at the end of the PowerPoint. If you're interested, you can look at it. I want to look at a few examples of this. This example, we want to solve the difference equation. B sub n plus 1 is 0.8, B sub n plus 4, where B sub 0 equals 5. That's the first part. Well, we are going to compare and contrast here and write the given. When we compare, this B0 or A is 5. This is R, 0.8, lowercase c is 4. So that's it's just a matter of comparison, everybody. Let's plug it into this formula. So you have this formula, B sub 0 or A, 5, lowercase c is 4, and all those r's are replaced by 0.8. Now we are going to use our algebraic technique to solve this. First and foremost, this is 0.2, and I'm going to take it out and put it under 4. It makes no difference. The reason I do that, I'm doing this algebraically because ultimately we want to find an easy format that we can take the limit of this is 40 divided by 2 or 20. Now we are going to distribute, and if you have a difficult time seeing what happens, you can literally change this to x. So you have 5x here plus 20 minus 20x. These two add up to minus 15x. We do this for the sake of part B so we can easily find the limit. So we are interested in finding the limit, everybody. All right, so we want to find this limit. And so what do we need to do? It's a very simple case of algebra. We are going to take the limit of this minus 15 times the limit of that using the limit laws, because if you recall from this theorem that the limit of r to the power of n as n approaches infinity depends on the value of r, this says this limit is 0, everybody. Okay. And of course, limit of a constant is itself. 20 minus 15 times 0 is 20. Very straightforward, everybody. All right, let's move on. Anybody wants to read this question? All you have to do, read it up to the end of part A. Anyone? Anybody would like to read this question for us all the way to the end of part A?
A patient is injected with the drug every 12 hours. Concentration will be reduced by 90% before each injection, and the new dose increases the concentration by 1.5 milligrams mg by milliliters.
Yes, perfect.
What is the concentration after 3 dosages?
Excellent. Thank you so much, Johnny. Perfect. So it's important to understand the question. So before we move on, part B is using capital C sub n plus 1 instead of B. So please understand all of this, the B will change to capital C. Now, before we answer those, I want to go with the most important part. Whenever you do word problem, you do write the given. So we want to see what's given. Because we are dealing with patients, B sub 0, and we said we're going to change it to C. C sub 0 or A is 0. The patient has no drug in the body to begin with, okay? Now, R is the percentage, the portion of a drug that remains in the body. So concentration will be reduced by this much. So what remains in the body is 1 minus that, or 10% or 0.1. And the new dose, how much is it? 1.5 milligrams per milliliters. That is constantly given. So this is from reading the question. And as long as you have that, everything else will become a piece of cake. But you have to write the given. Now, it says, what is the concentration after 3 dosage? They mean, okay, N C sub N. So fill it up. N is 1. So C sub 1 is 1.5. What happens when it's N is 2? We are going to give the same 1.5, but 10% of the previous one remains. So 1.5 plus 10% of the previous one. 0.1 times 1.5 which makes it 0.15 plus 1.5 is 1.65. Okay. Now, again, we have 1.5 for the third case, 1.5, and then again, 10% of this 0.1 times 1.65, which makes it 0.165 plus 1.5 makes it 1.665. All right, so we go to this formula, everybody, and change the B to C, capital C. Now we go to the given, replace the R with 0.1, lowercase c with 1.5, and we're done. So again, the importance of writing the given. You read this, and it doesn't matter how long it takes, how many times it takes to read it and understand it, you must write the given. For this part, we go to one of these formulas. So I'm going to write this formula, and I'm going to change the lowercase b to capital C. So that's the same formula, everybody. So b sub n becomes c sub n, c sub 0, r to the power of n, plus lowercase c times the parentheses 1 minus r to the power of n over 1 minus r. Now I go back to the given. Replace the c sub 0 or a with 0. Replace this r, and this r with 0.1. Replace the lowercase c with 1.5. And now I'm going to simplify this algebraically. To do so, since this is 0, obviously this product is 0. 1 minus 0.1 is 0.9, and I'm going to make the denominator of 1.5. And I'm going to write this as 15 over 9, which is 5/3. And this is the simplest format I can come up with C sub n. That will help me with the next part, which is finding the limit. However, what I want you to notice, if we choose n to be 1, 2, 3, and I highly recommend you try it, you get to the same table that we did in the first place. Finally, okay, I think the internet is acting up from time to time. That's amazing. Just quickly again, everybody can hear me. If somebody answers yes, I appreciate that.
Yes, we can hear you.
Excellent. Thank you so much. I appreciate that. So here's the last part of this question, everybody. We want to take the limit I'm going to use the limit laws. I'm going to take the 5/3 out, and I'm going to take a limit of each part, the limit of 1 as n goes to infinity, and the limit of this part, 0.1 to the power of n as n approaches infinity. And as you recall this, because 0.1 is between -1 and 1, this limit goes to 0. In other words, this is 0, this is 1. The answer is 5/3, and always write the proper units, milligrams per milliliters. Here's the last question. A doctor prescribes a 100 milligram antibiotic tablet to be taken every 8 hours. Just before each tablet is taken, 20% of the drug present in the preceding time step remains in the body. How much drug is left after the third tablet? Write the expression for Q sub n plus 1 and so forth. And the reason I read part B, because I want you to know that in these formulas, all of them, the lowercase b will change to uppercase Q. So with that being the case, we're dealing with patients and so forth. So Q sub 0 instead of B sub 0. Q sub 0 or A, that is 0. Can anybody tell me what is the lowercase c and what is the value of R as we read the question? Because I want to write the given first. It makes life easier to move on. So I'm looking for two things. Lowercase c, the amount of constant, or the ratio, the amount of the medication that remains in the body until we give the next dose. Anybody? So a doctor prescribes what? This much, 100 milligrams of antibiotic tablet every 8 hours. So that means every 8 hours, 100 milligrams, 100 milligrams. It keeps on going, the same amount. It's the lowercase c, the constant. How much remains in the body? 20%. So we're going to establish the table, and the first one is 100. So after the first dose, there's 100 milligrams of antibiotic in the body of the patient. 8 hours later, we go to the second one. Now it's Q sub 2. So this is Q sub 1. Now this is Q sub 2. We have the same amount, 100, and then 20% of the previous one. Previously, there was 100. 20% is 20, and 100 becomes 120. Can anybody tell me how much is here? Q sub 3. Well, again, the constant is 100, right? Now, 20% of this number, 20% of 120 is 24. They add up to 120. Okay, we want to write this expression, so we're going to go to this one and change the B to Q. So Q sub n plus 1 is RQ sub n plus C. We're going to replace the R with 0.2, C with 100. And we want to find the answer for Q sub n. So in this case, we change the lowercase b to uppercase Q. So B sub n becomes Q sub n. B sub 0 becomes Q sub 0 R to the power of n plus lowercase c. So this part doesn't change. Plus lowercase c times 1 minus R to the power of n over 1 minus R. Now, again, I go back to what I wrote as a given. Replace the Q sub 0 or A with 0. Replace this R, and this R with 0.2, and lowercase c with 100. And now it's time for algebra. 0 times anything is 0. So that's 0. 1 minus 0.2 is 0.8. We make it the denominator of 100. And this is the same as 1,000 divided by 8, or 125. So we have 125 times 1 minus 0.2 to the power of n, which means now it's in the format that it can easily be taken care of as far as the limits are concerned. Okay. Now, if we try 1, 2, 3, what do you think we get? We should get this table. I hope everybody tries this at home. The final part is asking to find the limit. So we're going to find the limit of this expression as n goes to infinity. So I can take the 125 out, that's using the limit, and take the limit of each part, the limit of 1 as n goes to infinity, the limit of 0.2 to the power of n as n goes to infinity. In which case, this, of course, is 1 minus, this, of course, is 0 because 0.2 is between -1 and 1. The answer is 125 milligrams of antibiotic.